Welcome to our first day of Unit 6. The sub should be passing out your new packets for this unit. There's no warm-up for today. We're just going to be jumping right into the new unit. So in your new packet, the first thing I want to draw your attention to is if you turn to the inside cover, you'll see in there is the reference sheet for the Regents exam. The ones that we will mostly use are on the left in this unit. The one that we will use a bit on the right-hand side, we have Pythagorean theorem on the top right. But from previous units, all of you have worked with the Pythagorean theorem, so that shouldn't be anything too new. The main formulas we will see in this unit are on the left there. So if we go over to the next page, today's topic is we're going to look at areas of different figures and composite figures. So composite figures are when there's multiple shapes put together. So first off, area of a circle. That is something that is going to be on your reference sheet. But we've got A is equal to pi times the radius squared. And just a reminder, remember the radius is halfway across the circle. So from the center to any point on the circle. Often questions might give you the diameter, which is all the way across, and you'll have to divide it by 2 to get the radius. Now on both the quiz and the test for this unit, you will be using the reference sheet. I'll have a separate copy of it for you to use. So you don't necessarily have to have that formula memorized, but it comes up so much in math, it wouldn't be a bad idea to have that memorized. Parallelogram area underneath it, you also get on your reference sheet. It's just area equals base times height. Now let's just draw ourselves a little picture of a parallelogram. So say this is your base. The height has to be measured as the straight up and down height, not that diagonal slanted side. The height is perpendicular to the base and it is straight up and down. The triangle on the left there, that's something else you get on your reference sheet. Triangle area is equal to 1/2 base times height. And again, base and height have to be forming a right angle together. If you've got two sides that are forming a right angle, then you can use those for the base and the height, but otherwise we need that straight up and down height that's forming a right angle. So those are the three that you get on your reference sheet. The ones that you don't get, a rectangle area, you can either think of it as base times height or length times width. Either of those is fine. If we move over to the right side, a trapezoid's area, we have 1/2 times height times base 1 plus base 2. And some different trapezoids. We'll make that one kind of look like an isosceles trapezoid. And here's another trapezoid. So in this one, we could call these base 1 and base 2. And the height, again, has to form a right angle. Here, if this was a right angle, we could call that the height. And then again, you have base 1 and you have base 2. So the bases in the trapezoid are the two parts that are parallel to each other. And the last one is a kite. So a kite kind of looks something like that. It's basically two isosceles triangles on the top and bottom. Now the kite formula you can get away without knowing, because you could, if you wanted, just split it into two triangles and do the areas of those two triangles and add them together. So you don't necessarily have to have the kite one memorized, but the kite formula, the area formula is diagonal 1 times diagonal 2 divided by 2. And our two diagonals connect any vertices that are not next to each other. So the blue and the green there would be our two diagonals. If you took the length of each of those and multiplied them together and divided by 2, that would give you the area of the kite. And again, if you didn't remember that, you could just do the triangle on top, triangle on bottom, and add them together. So today we are going to practice with these area formulas, and then we will also look at some composite figures where it's multiple formulas put together. So moving down to the bottom of page 1, we first want to identify what type of figure we have. This would be a trapezoid. So our area is 1/2 times our height. Now the height is always the distance between the bases. The bases are the two parallel parts. So in this case, the height of our trapezoid would be right here. Notice it's forming a right angle, so 180. Then we'll have parentheses. Next, we'd want to do base 1 plus base 2. We've got our two bases here and here. It doesn't matter which one you make base 1 and base 2. So we'll just do 200 plus 350. And we're going to pause the video for 1 minute for you to type that in your calculator, and also make sure you include your units. All right, for our area, we should have gotten 49,500. We have an area, so an area, your units are always whatever you have squared. So in this case, we'll have meters squared. So next we've got a portion of a circle. Well, for our formula, let's write A equals, then leave a little space, and then we saw from the previous page that we have pi times radius squared if it's a whole circle. So what we want to think about is what fraction of a circle do we have? Well, we're missing a chunk that has a right angle, so that's a quarter of the circle is gone, meaning we have 3/4 of the circle remaining. So for our particular shape, we just have 3/4 pi r squared because it's not the entire circle. Well, our radius, they tell us, is 4. So we're really going to have 3/4 pi times 4 squared. Now, any ones involving pi, you need to look at the directions. If it tells you to round, then you would put it in the calculator, including the pi. If it doesn't tell you to round, we are going to leave what's called either in terms of pi or an exact form. What that means is we're only going to calculate the other numbers and then just tack the pi on. This one did not say to round, so we will be leaving it in terms of pi. Well, 4 squared is just 16. So really, we're going to have 3/4 times 16 times pi. Now, you could just do in your calculator 3/4 times 4 squared, but I want us to talk through how you can be doing this without a calculator. 16 over 1 is getting multiplied by 3 over 4. So 16 is going to have two things that happen to it. It's going to multiply by 3 and divide by 4. Well, because of PEMDAS, multiplication and division can be done in either order. So if you're trying to do it without a calculator, do the division first, it'll keep the number smaller. So we can do 16 divided by 4 is 4, and then 4 times 3 will just give us 12. So we would end up with 12 pi is how we would read it. Again, you could have put in your calculator 3/4 times 4 squared and got the 12, but there's going to be instances coming up in your math careers where you're going to have to be able to do that without a calculator, so it's good to talk through that now and then. So we've got 12 pi. Notice they didn't give us units, but this is an area, so we would want to write units squared. Just to recap, if it tells you to round, then we would use the pi button on the calculator, which is down in the bottom left. We would put that in and then round to where they want you to round to. If it doesn't say to round, or it says to leave it in exact form or in terms of pi, you just calculate the other numbers and then you leave the pi on it. All right, moving over to page 2, question C. So what we've got here is we've got 4 congruent sides. So this is at least what's called a rhombus. So we know these are all 50. Well, if this is a right angle, in this triangle here, we can do Pythagorean theorem. Our C would be the 50. So we can do 40 squared plus b squared equals 50 squared. 40 times 40, well, 4 times 4 is 16, and tack on a 0 for each of them. Plus b squared equals 50 times 50, 5 times 5 is 25, and then tack on a 0 for each. We'll subtract the 1600 over, and that'll give us b squared is equal to 900. We'll take the square root of both sides. Now, when you take the square root of 900, we want to think, what's square root of 9? Well, that's 3 times 3, so one of the 3's goes out front. And then the 2 zeros is like you have 100, which is 10 times 10. So this would just be 30. Now, if you weren't sure of that, you can just do a menu number factor, and it would have given you 2 times 2 times 3 times 3 times 5 times 5. You would have a 2, a 3, and a 5 that would go out front, which would give you that 30. Well, notice all these triangles are the same. So to find our area, we're going to do 4 times, because we have 4 triangles that are the same, and then we'll just do the area of one of those triangles. So we're going to have 1/2, a base of 40, and a height of 30, because that base and height, notice, are forming a right angle together. Well, 4 times 1/2 just gives us 2. 40 times 30, 4 times 3 is 12, and then tack on the 2 zeros. 2 times 12 is 24, and tack on the 2 zeros. And then our units we would have is inches squared. So this one, we're going to show you 2 different ways we can do it. First off, you can do our kite formula. So you can do diagonal, which is 9, times the other diagonal, the whole thing is 12, divided by 2. Well, 12 divided by 2 is 6, so this is 9 times 6, which is 54 feet squared. So that's one way you can do it. Okay, but if you don't have that formula memorized, you can still do the problem, and you would do it by just splitting it into 2 triangles. Well, those 2 triangles are the same. They have the same base and they have the same height. So let's do area equals 2 times, and we'll just do the area of that purple triangle. We'll have 1/2 times our base of 9, and then the height would be 6. Well, 2 times 1/2 is just 1. 1 times 9 is 9, and 9 times 6 is 54. So notice it gives you the same thing. So most people, I would say, end up just doing the area of 2 triangles there rather than doing the kite formula, because you do lots of triangle areas in this unit. So it's usually a little easier to remember. All right, moving down to E, we're going to pause the video for 1 minute for you to try this one on your own. Make sure you have units on your answer. So we want to recognize a triangle. We've got area equals 1/2 base times height. Our base and height should form a right angle together, so we're using the 30 and the 13. When you punch that in your calculator, you should get 195 centimeters squared is our units. So going over to page 3, we're going to move now into composite shapes. So composite shapes means we have multiple shapes that are familiar to us combined. So what we want to do is we want to split our picture up into shapes we're familiar with. So we're going to draw a line down right there. and that's going to be our two shapes that we work with. And let's call this one A1, and we'll call this one A2. And we have two different areas we have to find. Well, for area 1, we just have a rectangle. So we just do length times width. So we'll do 12 times, and the second dimension for that is just the 16, because the 24 went all the way across. And if we did 12 times 16 in the calculator, we would just get 192 centimeters squared. Well, now for area 2, we have a triangle. Triangles are 1/2 base times height. So we're going to have 1/2 times. Our base and height have to form right angles with each other. So there's our base, and there's our height we're going to use. Well, the base matches the 12 that's over on the far left. Now for the height, we knew here to here was 16, and the whole thing was 24. So that means our height should be whatever the difference between the 24 and 16 is, which is 8. So our base is 12 and our height is 8. Half of 12 is 6. And then 6 times 8 is just 48 centimeters squared. Then to find your total area, all we do is we just add those together. So 192 plus 48, that would give us 240 centimeters squared altogether. So split it into familiar shapes, find those areas of the familiar shapes, and then just add them back together. Moving down to the bottom, we're going to divide this into a half circle. Oops, I drew my line a little high. A half circle and a trapezoid. Now you could split this into 3 shapes, a half circle, a rectangle, and a triangle, but I'm going to do a half circle and a trapezoid just for us to get practice doing the trapezoid one. So let's call this one A1 and that one A2. So for the first area, we have half of a circle. A circle is pi r squared. We have half the circle, so we'll just put a 1/2 out front. So for this area, we're going to have 1/2 pi times something squared, and I covered it up a little bit there, but the 30 goes all the way across, so that's the diameter. So half of that for our radius would just be 15. Notice there is nothing in this question that tells us to round, meaning we don't want to actually type the pi in the calculator. So what we're going to put in is we're going to do 1/2 times 15 squared. So we'll give you a minute to type in the 1/2 times 15 squared. And you should have one of two things. You could have either had 225 over 2, and we'll tack the pi on after, or when you divide by 2, it's a decimal that terminates, so we can do that if we want 112.5 pi. If your decimal did not terminate, meaning it ends, then you would have to leave it in fraction form. So either of these are fine for our area 1. Well, now for our area 2, we've got to do our trapezoid. Trapezoid is 1/2 times height times base 1 plus base 2. So we'll have 1/2. Our height is the straight up and down height, which was the 15. Base 1 plus base 2, it doesn't matter which you use for which, so we'll do 30 plus 48. And take a moment, type that in your calculator. We should get 585 meters squared. So to find the total area, we'll add them together. So again, we could have used either of those last two lines over there. I'm going to use the 112.5 pi plus 585. Now, these are unlike terms. It's kind of like if you have 7x plus 5, you can't combine those. It would just stay as this, two separate terms. Well, the 112.5 has a pi, The 585 does not. So you cannot combine those. This is our final answer in terms of pi. So all we would need to add on the end is our units, which is meters squared. So if you're in terms of pi, you can combine any like terms, things that have pi's or things that don't have pi's. But if they're not like terms, just leave them separate. All right, moving on to our last page for today, page 4. We've got James, and he's going to carpet the floor in the room that's shown. And we want to know how much it'll cost if it's $2.75 per square foot. Well, in order to find the total cost, we need to first find the square feet. Well, square feet for our units means we should be working with area. The units actually tell us what to do. This little flap here, this is just the door, just so you know. So we can kind of ignore that. That's just on the floor plan where the door would be. And we're going to split this into 3 shapes. Let's call this triangle area 1. We'll call this rectangle area 2. And we'll call that rectangle area 3. Well, area 1 is a triangle. So we're going to have to do 1/2 times a base times a height. Well, our base of this triangle, we could maybe think of it as being this. Well, that's not explicitly labeled. But let's see if we can piece this together. This whole thing they told us was 13. This part they told us was 2. That means that this part would be 11. Well, this whole thing was 15. This part of it was 11. That means that leaves us with 4 for that part. So the other part is coming from this whole dimension. Notice we have 5 and 5, so that whole thing is 10. So for the base and the height, one should be 4 and one should be 10. Half of 4 is 2, and 2 times 10 gives us 20 feet squared. And it's okay if you didn't put the units on your individual areas, but do make sure to include it at the end. For area 2, we've just got a rectangle. We've identified that the base and height for that rectangle are 10 and 11. So 10 times 11 will just give us 110 feet squared. And then our third, that little rectangle, you have a base of 5 and a height of 2. So we just have 10 feet squared. So for our total area, we'll just add all 3 of those up. And we get 140 feet squared. Well, we want to find out how much the cost is, and it's $2.75 per square foot. So what we're going to do is we're going to start with the 140 feet squared. And we're going to do this in a way that we will use later in the unit on another day. So this kind of leads us into that. We know that it is $275 or $2.75 per foot squared. Now, if it's per foot squared, that really means it's per 1 foot squared. And the word per means you're doing division. So what we do is we're going to multiply by a fraction. And we're essentially trying to convert the units here to just dollars because we want to know how much it costs. Right now, feet squared is in a numerator. The next time feet squared shows up, it has to show up in the opposite spot in the fraction. So feet squared will have to go in the denominator because currently it's in the numerator. And then we'll end up putting the dollars on top. So now we just fill in what we had. We had $2.75 per 1 foot squared. Well, now the feet squared unit wipes out on each. So when we multiply this, it'll just end up as a dollars amount. So take a moment on your calculator and do the 140 times 2.75. Dividing by 1 doesn't change anything, so you don't have to do the over 1 in this case. And when you get your answer, make sure to put the dollar sign on it for your units. And we should end up with $385. right, one last question for today. We got Hilda, and she broke this unusually shaped picture window in her parents' living room. The figure gives us the dimensions. Our replacement glass is going to cost $8 per square foot, and there's going to be a $35 installation fee. We want to find the cost of replacing the window to the nearest cent. So if we're rounding to the nearest cent, that means in the very end, we will want to put everything in the calculator and just round. But any intermediate answers, it's helpful to just keep as exact values. So the fact that you've got $8 per square foot, square feet is a measurement of area, so that really tells you what to do in the problem. It tells you to find the area. The units will often guide you in what you should be calculating. So we're going to split this up into some shapes. We've got these two tiny triangles here. We've got a half circle, and then we've got a rectangle. So let's call this area 1. We'll call this area 2, this area 3, and this area 4. So for area 1, we've got a rectangle. The base is 3, but we got to be careful with the height, because the 4 only goes from here to here, and then you've got a 1 there. So really, that whole height of the rectangle is 5. So 3 times 5 will give us 15 feet squared. For area 2, we've got a triangle. So it's going to be 1/2 base times height. Well, we've got one of the dimensions is this 1 right here. For the other dimension right here, well, notice they told us that this is 5, and this part down here was 3. Well, that means there is 1 to split up for the parts on either side. So this triangle is just going to be 1/2 of 1 times 1, which will just end up giving us 1/2 of a foot squared. For area 3, it's just the same dimension, so that'll also be 1/2 foot squared. And for area 4, we have half of a circle, where the radius was 5. So pi r squared is our circle area, but we only have a half circle, so we'll put a 1/2 out front. We'll put 5, or sorry, not 5. 5 was our diameter, so we want our radius, which you can either put in as 2.5 or 5/2. So we don't want to round to the very end, so let's keep this in terms of pi for right now. So I'd like you to take a moment to punch in your calculator, do the 1/2 times 2.5 squared. And for that, we should get 3.125 pi feet squared. If you had chosen to do it as 5/2 instead of 2.5, you would have had 25/8 pi, and that's the same value. So let's find our area all together now. We'll have the 15 plus the 1/2 plus the 1/2 plus 3.125 pi. Our like terms are just the 15, the 1/2, and the 1/2. So that'll give us 16 plus 3.125 pi feet squared. So to find our cost now, we have to take into account 2 things. We had to pay $35 up front for an installation fee. And then on top of that, we've got $8 per square foot. So we've got to do 8 times our number of square feet, which we found up above was 16.3.125 pi. And then they want us to round this to the nearest cent. So we're going to give you a minute to punch this in the calculator. Keep in mind, we are putting the pi button in this time. Pi is down on the bottom left. Okay, it'll have a pi on it. Select it and a menu will pop up, and just select the pi again to put it in. Okay, so use the actual pi button because it will keep it out all the way. So we'll give you a moment, type this in, see what you get to the nearest cent, and make sure to put your $ out front for your units. And cents, as a reminder, is 2 decimal places. So we should have a dollar sign on. Initially, we should have gotten 241.539 and some other stuff. The 9 bumps the 3 up to a 4, so we had $241.54. So hopefully in the future, Hilda plays a little bit more carefully in the living room, so she won't have to pay for that replacement. So that's it for this video. You got the day 1 homework, and have a great rest of your day.